All right, welcome back to day 2 of our work with solving absolute value equations. We reviewed yesterday that absolute value means distance from 0 on a number line. So when you take the absolute value of anything, what you're trying to determine is how many spaces it is away from 0. We discovered yesterday that most absolute value equations will have 2 solutions. There are a couple of special cases, but most will have 2. So yesterday, this was the kind of equation that you were solving. We have here the absolute value of x plus 2 is equal to 12. Now what I've advised you to do is to start out by looking at what's between the absolute value bars. In this case, it's x plus 2. So when I see the absolute value of x plus 2 is equal to 12, remember what we said. This is telling me that x plus 2 is 12 spaces from 0. So solving these problems depends upon me knowing what my absolute value is equal to. I've got, this is my distance. What I've circled over here is my distance, and I need over here to know what that distance is. And in this case, it's 12. So if x plus 2 is 12 spaces from 0, then x plus 2 can be a positive 12, or x plus 2 can be a negative 12. And we solve each one of those equations in order to see what x is. So we would subtract 2 on each side to find out that x could be 10, and then subtract 2 from each side to find out that x could be a negative 14. So the solution set for this problem would be 10 or negative 14. And again, we could check, plug in 10 for your x. 10 plus 2 is 12. The absolute value of 12 is 12. Negative 14 plus 2 is negative 12. Absolute value of negative 12 is 12. Now, I wanted to go back over that with you because we are going to make a slight change in our absolute value equations today, which is going to change a little bit of what we have to do to solve them. So over here, I want to show you the new kind of problem that we're going to tackle today. Now I want you to take just a moment to look at these 2 equations side by side and look at how they're different. And what you'll notice is that in the equation that I've solved over here on the left, my plus 2 is inside of the absolute value bar, so I am taking the absolute value of this entire quantity, x plus 2. If you look at the one over here on the right, my plus 2 is outside of the absolute value bar. So we're going to talk about what happens today when you have stuff like this plus 2 that is outside of your absolute value bars. So here's what I want you to do. Same thing. I want you to start by looking at what you're taking the absolute value of. In this problem, you are taking the absolute value of x. So this right here is your distance. Just like over here, what I circled was my distance. So this problem says that my distance equals 12. Is that the same thing going on over here? Is my distance on this side 12? And the answer is no. What this problem says is that if I take the distance from 0 for x and I add 2 to that then I'll get 12. So I want you to notice the thing that is different here. This 12 is not my distance. This 12 is the distance plus 2 more. So let me tell you what happens. When you have stuff outside of the absolute value bars, your first step has to be to isolate the absolute value part of the problem, which means I want to get this absolute value of x all by itself before I attempt to do anything else. So let's make sure we heard that and understand that, okay? When you have stuff like this plus 2 hanging around outside your absolute value bars, before you do anything else, isolate the absolute value, get it alone. So I want the absolute value of x to be alone. So how could I make that happen? Well, to get the absolute value of x alone, I need to cancel out this plus 2. To cancel out a plus 2, we know we would subtract 2. So I'm going to do minus 2. If I do it to one side of my equation, I have to do it to the other. So this 2 minus 2 would zero out. So that gives me the absolute value of x is equal to 12 minus 2, which is 10. So now I can see that the absolute value of x is equal to 10, which means that x is 10 spaces away from 0. I know now how far x is from 0. He's 10 spaces away. So if the absolute value of x is 10, then that means that x could be a positive 10 or x could be a negative 10. And that's a done deal. So my solution set would be 10 or negative 10. So as long as your absolute value is alone, like it was here, you're good to go. You can go ahead and make your two cases and solve. But when you've got stuff hanging around outside the absolute value bar, that adds a level of difficulty to the problem. You are going to have to isolate your absolute value before you consider the two cases and solve. So again here, let's show you this would work. Let's take 10 and plug it into x in the original problem. That'll give you the absolute value of 10 plus 2 is equal to 12. What is the absolute value of 10? That's 10 plus 2 is equal to 12, so I end up with 12 equal to 12. That checks. And if I plug in negative 10 where this x is, the absolute value of negative 10 plus 2 is equal to 12. The absolute value of a negative 10 is 10, so I get 10 plus 2 equals 12, which means that 12 equals 12. So the first thing you're going to do in all of these problems now is see if there's any stuff outside the absolute value bars. And if there is, you're going to get rid of it. You're going to isolate your absolute value first so you know exactly what your distance is. And then once you know what your distance is, then you can make your two equations. All right, so yesterday you would have solved, let me back up just a minute here. All right, here's the second problem we'll do. All right, so on this problem we have the absolute value of x minus 8 is equal to a negative 5. So we are taking the absolute value of just the x. The x is the only thing inside of those absolute value bars. So this right here is my distance. So is the distance negative 5? No. This says that the distance minus 8 is negative 5. So I have stuff hanging around outside my absolute value bars. So before I can solve this, I have to isolate this absolute value expression. I want it to be alone. To get this alone, I got to cancel out this minus 8. So you would do plus 8 on each side of your equation to isolate that absolute value. Your negative 8 and your positive 8 will cancel out, which gives you the absolute value of 8 is equal to negative 5, or the absolute value of x, is equal to negative 5 plus 8, which is 3. Now you know what your distance is. The absolute value of x is equal to 3, which means that x is 3 spaces away from 0. So what could x be? X could be 3 or x could be negative 3. So my solution set is x equals 3 or negative 3. So that's the thing that's going to be different today, is you're going to have numbers that are hanging around outside of those absolute value bars, and you're going to have to cancel those out to isolate the absolute value first, so you know exactly what your distance is, and then you can proceed like we did yesterday. So checking this real quickly, if I plug in 3 for x, that would give me the absolute value of 3 minus 8 is a negative 5. We all know that the absolute value of 3 is 3. So we get 3 minus 8 equals negative 5. 3 minus 8 is negative 5. So that checks out. Plug in negative 3 for x, you get the absolute value of negative 3 minus 8 is equal to a negative 5. Absolute value of negative 3 is 3. Minus 8 is negative 5. Negative 5 equals negative 5. So isolate the absolute value first, then split it into the two cases and solve. All right, so let's continue on. Let's add on a bit more. So adding a bit more to this problem, this says that 2 times the absolute value of x plus 5 is equal to 15. So what am I taking the absolute value of? Well, I'm taking the absolute value of x. So this is my distance. And I want you to notice that it is not isolated. This says that if I do 2 times the distance and add 5, then I'll get 15. So 15 is not the distance. 15 is the result of doing 2 times that distance and adding 5. So I need to isolate that absolute value before I try to solve for x. So if I'm going to get the absolute value by itself, I got to get rid of 2 things. I got to get rid of this times 2, and I got to get rid of this plus 5. Excuse me. Now you all will remember from our solving equations work that our last 2 steps in solving equations are to first add or subtract, and then last multiply or divide. So to get this absolute value by itself, the first thing I'm going to do is cancel out this plus 5. So I'll do minus 5 to cancel that out. That will give me 2 times the absolute value of x is equal to 10. Now, I'm going to cancel out this times 2. So I'll divide by 2, divide by 2. Cancel out those 2's. That'll give me the absolute value of x is equal to 5. So that absolute value has to be isolated. He has to be alone before you can finish solving the problem. So now I know the absolute value of x is 5. X is 5 spaces away from 0. So now I can figure out what x needs to be. If x is 5 spaces away from 0, then x can be 5 or x can be negative 5. So my solution set would be 5 or negative 5. All right, next up, 2 times the absolute value of x plus 3 is equal to 14. What am I taking the absolute value of? The answer is x plus 3. So this is my distance right here. So I want you to look at what this equation says. It says that 2 times the distance is 14. So 14 is not my distance. 14 is 2 times my distance. That's what will give me 14. So I need to isolate this absolute value before I can continue. So to isolate the absolute value, we will divide by 2 to get rid of that 2. So that'll give us the absolute value of x plus 3 is equal to 7. So now I know my distance. My distance is 7. X plus 3 is 7 spaces away from 0. So I know that means that x plus 3 can be positive 7, or x plus 3 can be negative 7. On these problems, let me say this real quickly. A lot of people right here are tempted to distribute the 2. Never distribute with absolute value bars. I should say that right up front. You need to isolate the absolute value, so you know exactly what the distance is, and then you can make your 2 equations. So if the distance from x plus 3's distance from 0 is 7, then here are my 2 equations. All right, now I'll solve for x. So minus 3 both sides will give me x equal to 4 for one possibility, and then minus 3 will give me x equals negative 10 for the other possibility. So x in this problem is either 4 or negative 10. Now, just so you can see that this works, let's check this one. Let's take this 4 and plug it in right here for this x. So that'll give us 2 times the absolute value of 4 plus 3 is equal to 14. We would do our grouping first, our group first. So 4 plus 3 makes this 2 times the absolute value of 7 is 14. We know that the absolute value of 7 is just 7. So 2 times 7 is 14. That checks out. That checks out. And then we can take this negative 10 and also plug it in right here. So that'll be 2 times the absolute value of negative 10 plus 3 is equal to 14. We'll do the group first. Negative 10 plus 3 is negative 7. The absolute value of negative 7 is 7. So we wind up with 2 times 7 equals 14. That checks out as well. So when you look at an absolute value equation, find your absolute value first. What are you taking the absolute value of? And then look to see if there is stuff outside of those absolute value bars. If there is, then isolate it. Get rid of those things. And then you can use your distance to set up your 2 equations and finish it off. All right, these last 2, we're going to go all out. So we have a negative 10 times the absolute value of x plus 5 minus 3 is equal to a negative 83. So let's get our eyes on the absolute value. What are we taking the absolute value of? We're taking the absolute value of x plus 5. So we're interested in how far that is from 0. So that means this is my distance. That absolute value is my distance. Now, is he alone? No. There's stuff outside. There's a negative 10. There's a minus 3. So I'm going to have to isolate that absolute value, what I circled, before I can solve this thing. So isolate first. Now, this is negative 10 times the absolute value minus 3. So we'll get rid of this minus 3 first. So plus 3 both sides will be our first move. That'll give us a negative 10 times the absolute value of x plus 5. And that's equal to negative 83 plus 3, which will put us at a negative 80. Now, to cancel out the negative 10, since he is multiplying, we will divide both sides by negative 10. So that'll give us the absolute value of x plus 5 is equal to 8. So now we're where we want to be. We know that our distance is 8 spaces. X plus 5 is 8 spaces from 0. So now we can do this problem. Since x plus 5 is 8 spaces from 0, x plus 5 could be a positive 8, or x plus 5 could be a negative 8. Solve each equation for x. So subtract 5 on both sides. We get x equals 3. Subtract 5 on both sides. X equals a negative 13. So solution set on this one, x can be 3 or negative 13. Now here's what I want to point out. Once we get to here, where I've drawn that red line, this is all what you did yesterday. You had your absolute value equal to a number. So that told you what your distance was and let you set up your two equations. This part above the red line is what's new. You're having to get that absolute value by itself so you can do what we learned to do yesterday. Trying to make that clear, trying to make sure it's clear. All right, let's do one last problem. 7 times the absolute value of 4x plus 8 minus 6 is equal to 106. All right, what are you taking the absolute value of? Well, the answer is you're taking the absolute value of 4x plus 8. So this part of the problem is your distance. And this problem is telling you that when you do 7 times the distance and subtract 6, then you get 106. I need to get the distance by itself. So do I cancel out the 7 or the minus 6 first? The answer is we cancel out the minus 6. If there's an addition or subtraction, get rid of it first. So you're going to do plus 6 on both sides. That will give you 7 times the absolute value of 4x plus 8 equal to 106 plus 6, which is 112. Now we will divide to cancel out the 7. And we get the absolute value of 4x plus 8 is equal to 16. So now we're where we want to be. We have isolated our distance. 4x plus 8 is 16 spaces away from 0 is what that equation is finally telling us. So now that we know that 4x plus 8 is 16 spaces away from 0, that means we know that 4x plus 8 has to be 16, or 4x plus 8 has to be a negative 16. And we solve each of those equations for x. So minus 8 each side gives us 4x is equal to 8. And then divide both sides by 4 to find out that x could be 2. Same thing over here, subtract 8. 4x is a negative 24. Divide both sides by 4. X could be a negative 6. So solution set on this problem is x equals 2 or negative 6. So we're adding on to what we did yesterday. Yesterday you started out with those basic absolute value equations where the absolute value was already alone. You already knew what the distance was. Today you're going to have stuff outside the absolute value bars. Isolate first. Cancel those things out first, and then do the same thing that you did yesterday. If you have questions or if anything at all in this video is unclear to you, then please let me know. Please contact me and let me help you. Y'all have a good day and good luck on your assignment. Thanks a bunch.